Dear follower, this semester my partners and I focused on one question. In what ways an airport is an urban information system? An urban information system is a lot of data stored, methodically organized and sorted by components that enable us to use it. All this data is used in the operation of the system and enables us to improve it. Okay, but why is an airport an UES? Let's see us with the Orly Airport. It's the second largest airport in France, with his two terminals, south and west terminals, his 4 hours and 3 runway. 13 million traveled through Orly Airport in 2018. As the running of an airport is very complex, we will focus only on the movement of passengers and their luggage between the entrance to the hall and boarding system. Let's use through diagrams. This functional tree, we can see that a city is organized in some parts, like transport, health, train, and security. Each part is subdivided in many other parts. In transport, for example, we have bus, train, and finally, airport. Let's begin to discover the airport system with Abdel.
So now we'll see the global running of the airport. In this system, it's more focused on the communication and services. So we can split the airport in three parts: the store services, the aerial company communication, and the arrival services. First of all, the customer is faced with the store services such as booking a trip, a hotel, and check-in. After that, we have the service concerning the plane, so the aerial company communication to tell you which destination is served. And finally, we have the arrival services that include transport, practical services, baggage gesture and financial services. We're going to see a DFG context diagram to understand a little bit more about the different actors and how they interact with the airports. So as you can see on the diagram, we have the airport in the center of many entities linked by data flow. So they are considered as inputs, and they interact like the airport give boarding pass and luggage information, and the passenger give back personal information. Or another example, the airport give flight information to the screen and so on. So just a constant exchange of data between the airport and his components. So now we'll see analysis.
Now we will see the processes with more details. Let's start with an overview of our system. For that, we use class diagrams. These UML diagrams are used to show the different objects of a system, their attributes, their operation, and the relationship among them. In this diagram, classes are represented by boxes divided in 2 or 3 parts. At the top, you can find the name of the class, for example, client in our system. In the middle, you can find the class's attributes. For here, the client's information. On the bottom, you can find the possible operation. For clients, they can search for flights or book a reservation. Classes are interrelated to each other in specific ways. For instance, flight and book are related by an association, whereas security and passenger by a realization.
Let's now go back to another DFD diagram. So this is a level 0 diagram. So comparing to the previous context diagram that we saw, there are more details in this one. So although the design is still the same, so you can still find the external entities with a rectangle, the flows with arrows, A few changes occur within this diagram. So the internal operations are represented. So you can see here 4 different operations. So booking a flight, the passenger checking, the luggage checking, and scheduling the flight. As well as we can see the data stores, so to see how the data is treated between 2 operations and how it is stored within the system. So in this specific diagram, as I said, there are 4 different operations that we have chosen, but we could have represented more of them because there are a lot of different operations through these systems. So we are now going to develop each operation, and let's start with booking a flight. So I'm handing over to Ines for this part.
This use case diagram details here what happens exactly when a passenger wishes to book a plane ticket. Passengers have 2 choices: book online or ask a travel agent. Finally, the reservation is recorded, then paid and sent to the database. And now let's see what happens at check-in with Axel.
So let's now see the second operation that occur in an airport, so the passenger checking. So among other diagram, we designed a DFD diagram. So the design is still the same than the others, but this is a child diagram, so the external entities are not represented in this one. So basically, to realize the checking, you have to start by verifying the boarding pass, then you establish your boarding pass, and finally you issue your cabin luggage. So you can see here how the flows goes from the passenger information to the different data stores. So this is a quick and simple diagram that can offer a global view of the operation.
We choose to develop the luggage conveyance with an activity diagram. This UML diagram depicts a series of actions of control in a system. First of all, you can see 3 swimming lanes: passenger, airport, and plane. In our example, it starts with the passenger who goes to the check-in counter. Then the passenger embarks while his luggage is loaded on the plane. After the plane laid off, the passenger debarks. Meanwhile, his luggage is taken off of the plane's hold. There is 2 actions which happen in the same time, so we use a fork and a join to represent that. The diagram ends when the passenger picks up his luggage at the airport. Now let's go back to what happened for the passenger after his check-in. We choose to expose a sequence diagram of a passenger's boarding. The sequence diagram depicts interaction between objects in which these interactions take place. The passenger goes to the check-in counter where his ticket is verified. Once the ticket is confirmed, the passenger drops off his luggage. The luggage is loaded in the plane. Meanwhile, the passenger gets the boarding pass and goes to the boarding gates. The staff of the boarding counter check the passenger boarding pass, and if everything is okay, the passenger gets the authorization to embark in the plane. Now, let's see what's the different interface the passenger will encounter with Abdel.
So throughout the process of boarding a plane from walking to check-in, you will use different interfaces. For reservation, you can choose traditional ways such as travel agencies or through booking website. Either way, it's the first interface you will encounter, so it must be as intuitive as possible. You can do research according to criteria, consult price, and timetable, and so on. Since the outbreak of the COVID-19, the website is on duty to assist our valued customers. So that's why the interfaces are a crucial element. When the flight days come, you go to the airport, and to save time, you can use a check-in kiosk. Thus, let you check in and print your boarding pass, tag your baggage, and manage your seat placement. You can also change your flight for same-day travel or find alternate flight if there are a problem with yours. The tiny detail that makes the difference is the access to a wide choice of languages and the option to have vocal instruction for blind people, for example. This tool permits the passenger and the airport staff to gain a large amount of time. So now we'll see the database schema in the next sequence.
So the diagram shown is the database schema. It's very useful to program the SQL code. SQL is a non-procedural language, and this is closely related to relational algebra. It's used to create database and relations, data tables and relations between them. It's very known because it's very easy with the SQL to get an information with a precise request. So there are two parts of the language we'll see in this project. The data definition language and the data manipulation language. The data definition language is used to create tables and to insert values into it. Here we see a table named profile, and we put some information in it with the function insert into and values. And the data manipulation language, it's to get an information with a request. So here we can see that we selected the ID from the table profile to get the number ID of a person named Balboa. So Ines is going to present us the innovations.
I'm going to introduce the innovations we have developed to improve the airport. The first is to create dematerialized identity papers in order to passengers can board directly thanks to a facial recognition. The second is an electronic chip installed in luggage so that it can be found at the arrival or in the event of loss. The last one is a GPS application that allows users to find their way around the airport based on the information of their plane ticket.
So that's an overview of how an airport works. We detailed here the way of passengers and their luggage and the booking system. These parts are already complex. After spending hours studying the airport and its systems, we had become mini experts. Next time, we will take a plane, we hope in a foreseeable future, and for a beautiful destination. Thanks to our work, we will live the experience with other eyes since we know what happens in backstage.